Alright, so in today's tutorials, we want to look at exploratory data analysis in Python using Jupyter Notebook. And to begin with, first of all, we have to basically import or load our data set. But before that, we have to ensure that we use a library known as the Pandas Library. So first of all, we can install and load the Pandas library. This library is very essential because it is one of the software library for data manipulation and analysis. Right, it also offers some data structures and operations for manipulating some numerical tables, and it contains most of the functions that we can use to even import our data set. Right, so if you have not installed the Pandas library, then you have to use this function pip install pandas, right, to basically install it for the first time. But if you have already installed it, then you can skip this line and just import the or load the library by making use of this import pandas as PD. PD is just a short form of pandas, right? So this is basically how you are going to load the pandas library. So let's quickly run this. Alright, so once we load this library, it's still compiling, so you see an asterisk in this square bracket. Once it's done, you will see a number in the square bracket. So once we have loaded this library, we can then proceed to import our data set, right? So let's import or load data set. So I'm going to give a name to this data set as IDAT. We are going to use the iris data, and it is in a CSV file format. So we are going to use the pandas library and use read underscore CSV, right? And the name of the data set should be in your current working folder, right? So if I go to the folder where I have my Python source file, you see the data set also in the same folder, right? So if you look at this, I have the iris data. I'm going to leave this data set in the description of the video so that you can download and upload it in your current working folder. So make sure that this data set is in the same folder where you have your current or where you have your Python source file, right? So now let's proceed. So the name is irisdata.csv. I'm going to use the same thing, irisdata.csv. And if you have not watched my previous tutorial on how to import data set in Python, you can go watch that. I've done several videos on how to import different data types in Python. You can go watch that before you jump into this, right? Okay, so this is how we are going to basically import or load the library, load the data set. So let's quickly run this. So shift enter. So here we go. So we can view our data set. So I want to view data set. So I'm going to just run the same IDAT, right? I don't need a head, so let's run so that it can give us the first 5 observation, the last 5 observation. So shift enter. So here we go. This shows us the first 5 observation of our data set and the last 5 observation, right? And this is the iris data set, which was introduced by Ronald Fisher. This data set consists of 50 samples from each of the 3 species. We have Setosa, we have Versicolor, and we have Virginica, right? 4 variables were measured from each sample, which included sepal length, sepal width, petal length, and petal width. And based on this combination of these 4 features, Fisher developed a linear discriminant model to distinguish the species from each other. This is the data set we are going to use for the EDA, right? And this are all in centimeters. The units of measurement for this measurement are in centimeters, right? So once we have viewed our data set, we want to get more details of this data set. So let's look at the structure of the data set. Structure of data set. So I'm going to say IDAT, that's the name of the data. Info. For Python, you have to use info, right? So structured data set, shift enter. Okay, so here we go. So we can see that we have 150 entries, which basically means 150 rows from 0 to 149. We have data columns to be 5, which include the first one has to be index at 0, which is sepal.length, and the data type is float, which is basically numeric. The same applies to the second variable, which has been index 1, right, which is sepal.width, and the data type is float. We can also see peta.length, peta.width also have the same data type, and the last variable has been index 4, which is species, and the data type is an object. But we know that this is basically the same as a character or a string, but this is supposed to be a categorical variable. So in our data preparation stage, we are supposed to convert this into a categorical variable or into a factor so that we can have the levels of the factor, right? So let's look at the dimension of our data set. So dimension of data set. So I'm going to say IDAT dot shape, right? Shift enter. So this basically gives us 150 rows and 5 columns, right? Now we can proceed to the data preparation stage. So let me comment on this and say 1. So I want to start with data preparation. So this is basically important because data preparation is basically all about cleaning the data so that the data becomes ready to be used for model building or for analysis, right? And we are going to look at some of the things that entails data preparation. So let me change this to Markdown. Alright, so shift enter. Alright, so in data preparation, the first thing that we want to look at is basically 1.1. Let's say you want to check for missing values. Check for missing values. Yeah. So let's change this to Markdown. So this. So Markdown. Shift enter. Right. Alright. So how do we check for in preparing our data? How do we check for data preparation? Think preparation. Yeah. Shift enter. Okay. So how do we check for missing values? First of all, the name of our data set is IDAT, right? So we're going to use this function is null, right, to basically look, check for the missing value. So let's say this, shift enter. So it will go through the data set for each variable and look at the data point. If there is no missing value, it will indicate that's false, right? And we can see that in this output. So you can see that in between here we can see those values. So if there are any missing values, we cannot see it because it's just given as the first 5 and the last 5. So in order to see if there's any hidden or missing values, let's add this function sum to basically count the number of missing values in our data set if there's any. So shift enter. Alright, so now you can see that for separ.length it has one missing value. Separ.width also has one. Peta.length has one missing. Peta.width also has one, but for species variable there's no missing. So in order to check for this or correct this, we have two ways. Is either we can remove these entries, or another way is to do data imputation whereby we will look for the average value for the separ length and replace it with the missing value. We do the same for the other variables, right? But in this case, because the missing value is just one, right, and it's in the same entry, we can just go by the dropping this entry with the missing value, right? So I want to now remove entry with missing values. Yeah. So how do we do that? So this is going to be my first stage of data preparation. So I want to assign this to that prep one, right? So I want to remove those missing values. I'm going to use this function drop NA, right? So this is basically going to remove those entries with missing values. So let's run this. Okay, so let's look at the dimension. So that prep one does ship. So I want to basically like check the dimension of new data set. So let's see. And now we can see that we have 149 rows with 5 columns, meaning that there was one entry that has these missing values. So it has basically deleted it. And now we have left with 149 observations of with 5 variables, right? Okay, so the next thing that we can also look at is to check for duplicate values. So now I want to 1.2, right? We now want to check for duplicate values. So how do we do that? Let me change this to Markdown. So Shift Enter. So to check for duplicate values, we are going to use a function known as duplicated. So this we are now going to depend on the first the data preparation at the first stage, which is that prep one, right? And say duplicated, right? So if you run this, let's see what we get. So it's going to go through each of the entries or the rows to see which one of them has been duplicated. So for the first entry is this false, false meaning that there's no duplicate. But if you look in between, maybe there may be some duplicate, but we are not going to see that. So how do we basically get those or basically check for that? So let's use dot sum to count. So we can see that in here we have one which is hidden, right? So how do we extract that duplicate value? So we want to extract entry with duplicate, right? How do we extract those entry with duplicate? So um, from our data preparation, the first stage, prep one, I'm going to use a function known as the LOC function or the location indexing function. This function will basically help us to retrieve data values from a data set, right? Basically, it can help us to specify rows or columns based on their rows or column labels, right? So I'm going to say that prep um, one dot duplicate, right? And I want to say keep should be false, right? So this is basically the column indexer and this is basically the row indexer, right? So it's going to go through all the rows and check which of the values have duplicates. So we are saying keep should be false because we don't want to keep either the first or the last. We want to see all the entries that are made up of all the row entries that are made up of duplicates, right? So let's quickly run this. Shift enter. That, sorry, that prep one. Yep. So let's run this. Okay, so we can see that in this row entry is it 101 and 142, they have the same input, right? You can see that it is Virginica. If this was supposed to be Setosa, then it wouldn't be a duplicate. So you can see that the same entry. So this might be a mistake. So in cleaning our data or preparing our data, we have to check for duplicate instance and either keep the first one or remove the last one and keep the first one, or keep the last one and remove the first one. So we want to now remove entry with duplicate, right? So how do we do that? So this is going to be my second stage of data preparation. So I'm going to assign this to that prep 2, right? And say from that prep 1, right? I want to drop duplicate, right? Duplicates, yeah. And in this, I want to keep the first one, right? So basically, I want to keep the first one and remove. Maybe it might be a mistake, right? So, or you can either keep the last one and remove the first one. So which way? So let's run this. Shift Enter. So let's look at the dimension. That prep 2 the ship, right? Sorry, ship. So check for dimension. Check for dimension. So let's run this. So we now have 148 rows with 5 variables. So it has removed. First we were having 149 rows. Now it has reduced to 148 rows, right? Because it has removed the one of the entry with duplicate, right? So I think we are good to go. Okay, so now one thing that we also have to look at is basically, you know, earlier I said that this levels of the species were string or they were object, right? And we're supposed to convert this species into a categorical variable. So, data preparation is very important. You also do that. If you have an object or a character, or let's say you have a type of categorical variable, but Python doesn't see it as a categorical variable, you are supposed to basically do those changes by converting those variable into a categorical type. So how do we do that? So there's going to be the third part of it. This is 1.2. We now have 1.3, which is basically to convert the object type into categorical variable or into categorical type, right? The object type is basically a character or a string type. I want to convert into a categorical type, right? So if you can check, let's quickly check that. If you check this, that prep 2 data types, you can see that a species is an object, but this is not supposed to be. You're supposed to ensure that this becomes categorical. So that's basically what we want to do. So let me copy this, yep, and do it here, paste. So let me change this to markdown, yep. So shift enter. So I want to convert the object type into categorical type. So how do we do this? So I'm going to say from that prep 2, where I want to extract the species, so species variable, and I want to write the same that prep 2. I want to extract species, right? But this time I want the data type. I want the data type should be categorical. So category. Yeah. So let's run this. Okay. So this is just a warning message, right? So now if we check that prep 2, the data types, let's see. So you see that this has been changed into categorical variable. So first it was an object, but now it is a categorical variable. So there's going to be the last stage of data preparation. So I want to assign the that prep 2 or the data preparation at second stage to final dat or final data. So I want to use dat for final dat or for final data. and basically assign the dot prep2 to it. So instead of making use of this is my final stage of the data preparation. That's why I'm doing this assignment. So let's run this. Alright, so now let's look at fdat, which is basically the same as that prep2. Right, so let's look at the info. So we now have 148 entries, 5 columns, right? And now the species has been turned to category, right? These are all numerics. So we are good to go now, right? Now I think one thing that I can add to this is data filtering. Sometimes you may not, let's look at the herd. You may not be interested in working with all these um, data entries together with some of the variables. You may like to filter some of the variables. So let's look at how to do this. Data filtering. Data filtering. Yep. So change this to Markdown. Shift enter. Right. So in a case where you're not interested in working with all the observations, or let's say some of the, you may be interested in working some of the variables, then data filtering is very important. So let's look at how we can do this. Let's say for the first part, we want to extract the Setosa and the Virginica species, right? We don't want to use all the species variables. We just want the Setosa and Virginica, right, together with all the for measurement. So how do we do that? I'm going to assign this to that F1, data filtration 1, right? So for my final that, yes, I want to basically extract that of the Setosa, so species, and I want to get that of the Setosa, right? And or let me use the or symbol, yeah, or let me copy this. Yep, paste. Now I want Virginica. Okay, so let's run this. Shift enter. So let me add one more thing. So now let's look at our data filtration 1. Let's look at the info. So now we have 98 entries, right? And we also have our 5 columns. So if you look at the herd, it has just extracted that of, let me run everything. So it has just extracted that of Setosa and Virginica. That's why we have 98 rows, right, together with all the 4 measurements. So this is basically how to do it. Now let's suppose you can see that with a separate length in here, some of the values are more than 5, some of them are below 5, like the first, this one, this, they are all below 5, right? These are below 5. So let's say we want to add one more condition to this data filtering. We want to add a condition whereby this separate length values will be greater than 5. So let me copy this. Let me copy this. Yep. So let me scroll down. Oh, let me data filtering, shift into, okay. So let me copy and paste. So data filtration 2. Now I want to add a condition to it and say, so this is the first part. So let me put it in another bracket. So after doing this, I want to add another condition and say, and I want my species.length, sorry, sepal.length, right? I want it to be greater than 5. So now let's look at it. Shift enter. So you can see that now, even though we have just extracted out of the Setosa and Virginica of the species for the 4 variables, we can see that now for SEPA the length entries are more than 5, right? As compared to this, where some of the entries are below 5, right? You can see that now the SEPA the length entries are more than 5. Now the last thing that maybe we want to do is we don't want to use all these variables or measurements. Maybe we want to extract just 2 or 3 of them. So how do we do that? So I've already copied this. Let me paste it here. Paste. So data filtration 3. Now after doing this, let's say I can either just ignore this and make use of final data 1. Sorry, the data filtration at the first stage, right? But let's continue. So let's say I want to filter. I want to filter this variables. Let's say I just want to filter separ.width and petal.width. So let's do that. So I want separ.width, separ.width, and let's say petal.width. Right. So this one way to do it, I can either ignore all of this and just use the data filter 1 to basically do that instead of writing the whole of this, right? And just copy this and just write that F1, right? So that's another way to do it. So so let's run this, shift enter. So here we go. So we have 198 rows of 2 columns. Instead of having 4 columns or 4 variables, we now have 2 features or variables, right? So this is basically how to prepare your data for analysis. So this is the data preparation stage, right? In our next tutorial video, we'll be looking at how to do the explorator analysis on our prepared or clean data.